Hi everyone. Today we'll discuss about the most important topic in EDC, that is a compulsory question in examinations, that is a external examination, that is exact analysis. Exact analysis, Unit 5, that is analysis of transistor amplifier circuit using H parameters. Analysis of transistor amplifier circuit using H parameters. In this amplifier circuit, he may give analysis of transistor in CE configuration using H parameters, analysis of transistor amplifier in CB configuration or CC configuration using H parameters. Here we have to find voltage gain, current gain, input impedance and output admittance. He may ask some parameters or all parameters. So the first circuit is nothing but basic circuit, that is amplifier circuit, amplifier equivalent circuit. So for amplifier we have to give some input signal, that is Vs. Vs we have to give as input signal through Rs, source resistance Rs, and next we are going to collect the output across the RL, load resistance, RL load resistance. It may be ZL, load impedance. You may take any manner, no problem. And the transistor amplifier circuit may be common emitter configuration, common base configuration or common collector configuration. For all configurations, one unique derivation we are seeing. If in the examination he may give common emitter configuration, in place of H parameter you may take HFE, HOE, HRE and HIE, like that you can write. That is nothing but exact analysis of the transistor amplifier in CE configuration. Like that we can able to write the answer. So common model for both all the configurations I am explaining here, that is analysis of transistor amplifier circuit using H parameters. This is common circuit. It may be any configuration. In place of transistor amplifier, it may be common emitter, common base, common collector. Okay, this is the basic circuit. For example, let us take our transistor is a two-port network. Two-port network is nothing but it is having input voltage and input current, input voltage and input current, and output voltage and output current. Two-port network is consisting of input voltage and input current, output voltage and output current. Here I1 V1 input port, I2 V2 output port. This is a basic transistor two-port network. We are taking H parameter model. H parameter model, hybrid model we are taking. There we have two parameters. So our equivalent hybrid model circuit is like this. Equivalent hybrid model for the transistor amplifier is this one. So this Rs and Vs, this Rs and Vs are additionally we are taking, and RL also additionally we are taking. So without Rs and Vs and without RL, the circuit which is having, that is equivalent hybrid model circuit. Equivalent hybrid model circuit for transistor amplifier or transistor two-port network. For the transistor two-port network, this circuit up to this circuit is nothing but equivalent hybrid model circuit without Rs and Vs and ZL. If it is acting as a amplifier, we have to take Vs and Rs and output across the RL. Then the input current is I1, output current is I2, input voltage is V1, output is V2, and output we are going to collect across the load resistance. For this hybrid model circuit, we have to find the current gain, voltage gain, input impedance and output admittance. So here, before going to discuss about that parameters, those parameters, we have two hybrid parameters. One is V1 is equal to HI into I1 plus HR into V2, and I2 is equal to HF into I1 plus HO into V2. These two parameters you have to remember. Compulsory we have to remember these two formulas. Based on these two formulas, we can derive all the parameters. Let us take current gain. The first parameter, current gain, AI is equal to, what is the current gain formula? Output current by input current. In this circuit, what is the output current? In this overall circuit, the output current is IL, input current is I1. Input current is I1. IL by I1. IL by I1. We know that IL and I2 both are equal, but both are in opposite direction. Both are in opposite direction. IL and I2 both are equal and opposite direction. That is why IL is equal to minus I2. I am substituting in place of IL minus I2, and I1 as is I am writing minus I2 by I1. Let us take that one as the current gain formula, equation 1. Then here we have I2 and I1. Whether it may be I2 equation or I1 equation, you can take and simplify and find the current gain. if you observe our H parameter equations, we have I2. That is why I am taking equation number 2. From H parameters equation 2, I2 is equal to HF into I1 plus HO into V2. These two formulas we have to remember for any configuration. Compulsory we have to take. We have to remember, and here I am taking second equation. From H parameter equations, I2 is equal to HF into I1 plus HO into V2. That is a second equation. And we know that another formula is V equal to IR. The output voltage V2 is equal to IL into RL. V equal to IR, Ohm's law. V2 is equal to IL into RL, and we know that again IL is nothing but minus I2 into RL. This V2 value I am substituting here in the second equation. V2 is equal to minus I2 into RL. I am substituting in the second equation. Then I2 is equal to HF into I1 plus H0 into HO into V2 is nothing but minus I2 into RL. Then here we have I2, and this complete I2 term I am taking to the LHS side. I2 here minus we have that becoming plus. I2 plus HO into I2 RL is equal to HF I1. In those two I am taking I2 common. Then if you take I2 common, 1 plus HO into RL is equal to HF into I1. So then from this I am going to find I2 by I1 is equal to HF by 1 plus HO into RL. We know that from equation 1, what is current gain? AI is equal to minus I2 by I1 minus, what is I2 by I1? HF by 1 plus HO into RL. In this formula we have minus I2 by I1. Here we have that I2 by I1 is substituting here. AI is equal to minus HF by 1 plus HO into RL. For example, he may ask in the examination, find the current gain for the common emitter configuration using hybrid model. You may take Vs, Rs in place of Hi, Hie, and in place of HR, HRE, and in place of V2. For common emitter configuration, output current is VCE, HR into VCE. Input current for common emitter configuration, input current is IB, and in place of HF we can take HFE, and input current is IB, HFE, IB, and output current is IC. Collector terminal is the output current, then output current is IC, and in place of HO you can take HOE, and in place of V2 you can take VCE, RL as it is, RL and IL as it is. This is the H parameter for CE configuration. And from that again you can write the formulas and you can substitute in current gain equation, find AI. You may get minus HFE by 1 plus HOE into RL. Again, no need to draw the circuit. If you want to find H parameters for common emitter configuration, after deriving this you can write current gain for common emitter configuration. For CE, AI is equal to minus HFE by 1 plus HOE into RL. You may directly write current gain for CE configuration is equal to minus HFE by 1 plus HOE into RL. In place of H parameters, the second suffix you can indicate as the configuration. This HFE second suffix is indicating the configuration. That is a common emitter configuration. If it is a common base configuration, in place of this you can write HFB by 1 plus HOB into RL. That is a current gain. Similarly, you can find this remaining parameters. The next parameter is input impedance. Zi is equal to, we know that input voltage by input current. Input impedance Zi is equal to input impedance Zi is equal to input voltage by input current, V1 by I1. So from H parameter equation 1, here we have V1 and I1. So we have V1 and I2 equations. That is why I am taking V1. Here we have V1. That is why I am taking V1 equation. That is nothing but H parameter equation 1. V1 is equal to Hi I1 plus HR into V2. This equation I am taking and dividing both sides with I1. Why? Because I want V1 by I1. So then V1 by I1 is equal to Hi I1 plus HR into V2 by I1. Then V1 by I1 is nothing but Zi. Zi is equal to here Hi I1 by I1. I1 will get cancelled. Hi plus HR into V2 by I1. HR into V2 by I1. Then we know that V2 is equal to minus I2 into RL. The current gain, while deriving the current gain equation, we wrote that V2 is equal to minus IL into RL. IL is equal to minus I2, then minus I2 into RL. That one I am taking. So Zi is equal to Hi plus HR into, in place of V2 I am substituting minus I2 into RL by I1. Then Hi is equal to Zi is equal to Hi plus HR into minus I2 by I1 into RL. Minus I2 by I1 I am writing separately into RL. Why? Because we know that minus I2 by I1 is equal to current gain. Already we derived that. We know that from the first equation minus I2 by I1 is equal to AI. Then I am substituting in place of minus I2 by I1 AI. Then Zi is equal to Hi plus HR into AI into RL. In place of minus I2 by I1 we got AI. This is one equation. This is one final equation. If you know current gain, directly you can take this equation and find Zi, input impedance. Otherwise, if you don't know AI, then Zi is equal to Hi minus HR. Why? Because AI I am substituting. AI is equal to minus HF by 1 plus HY into RL. Current gain is equal to minus HF by 1 plus HY into RL. Minus into plus becoming minus, that is why minus HR HF RL by 1 plus HY into RL. Then Hi is equal to, Zi is equal to input impedance, Zi is equal to Hi minus, here I am taking RL common. In the second term I am taking RL common. Then HR HF by, if you take RL here common, 1 by RL plus HO. Then RL get cancelled. Both will get cancelled. Then Zi is equal to Hi minus HR HF by 1 by RL is nothing but YL. 1 by RL is nothing but YL admittance plus H0. This is another formula. Zi is equal to Hi minus HR HF by YL plus HO, output admittance. This is another equation for input impedance. Similarly, we can go for the next parameter, voltage gain as well as output admittance. Next parameter is voltage gain. The next parameter is voltage gain. AV is equal to V2 by V1. Output voltage by input voltage. V2 by V1. Output voltage by input voltage. V2 by V1. Again V is equal to IR. I2 into RL by V1. I2 into RL by V1. That is equal to I2 into RL by V1. Again we know that current gain is equal to, here current gain is equal to I2 by I1. Then I am substituting I2 is equal to AI into I1. Here voltage gain is equal to V2 by V1. V2 is equal to minus I2 into RL by V1. Minus I2 into RL by V1. I am substituting in place of minus I2 as AI into I1. AI is equal to minus I2 by I1. Current gain equation already we derived. AI is equal to minus I2 by I1. Minus I2 is equal to AI into I1. AI into I1 into RL by V1. So AI into RL. I1 V1 is nothing but Zi. V1 by I1 is nothing but Zi. I1 by V1 is nothing but 1 by Zi. I1 by V1 is nothing but 1 by Zi. So AI into RL by Zi. Directly we can write voltage gain equation in terms of input impedance as well as current gain. AV is equal to AI into RL by Zi. Similarly, you can go for output admittance. Next parameter, output admittance. Y0 is equal to, we know that output current by output voltage. I2 by V2 with Vs is equal to 0. If you want to find output admittance, Vs should be 0. Then I2 by V2 from equation 2. Why? Because here we have I2 and V2 terms. If you observe H parameter equations, we have V1 and I2. So second equation we are taking. Why? Because we have I2. From second equation, I2 is equal to hf into I1 plus h0 into V2. Divide the term by V2. Why? Because I2 by V2 we want. Divide both sides with V2. I2 by V2 is equal to hf I1 plus ho V2 by V2. Then what is I2 by V2? Nothing but Y0, output admittance. Then hf into I1 by V2 plus h0 into V2 by V2 get cancel, ho. This is the fourth equation. Y0 is equal to hf into I1 by V2 plus ho. Here we don't know I1 by V2, that we have to find. If you want to find that one, when Vs is equal to 0, we know that when Vs is equal to 0, we are going to calculate the output admittance. So when Vs is equal to 0, apply KVL to the input loop, apply KVL to the input loop, apply KVL to the input loop. When Vs is equal to 0, then Rs into I1, the current flowing through this is I1, Rs into I1 plus Hi into I1 plus Hr into V2. This is the KVL equation is equal to 0. Here I is common, in those I1 is common, then I1 into Rs plus Hi. This one I am taking to the RHS side, minus Hr into V2, then I1 by V2 is equal to minus Hr by Rs plus Hi. From this equation I am going to find I1 by V2. Why? Because in this fourth equation the unknown is I1 by V2 when Vs is equal to 0. Then substitute this I1 by V2 in the fourth equation. Then you will get output admittance as H0 minus Hr Hf by Rs plus Hi. Here Ho minus, Y minus means I1 by V2 is minus Hr by Rs plus Hi. So Ho minus Hr Hf by Rs plus Hi. Similarly, here we have another two parameters, AVS and AIS. When we consider voltage source resistance Rs also into consideration, then current gain and voltage gain. Nothing but overall voltage gain is AVS, overall current gain is AIS. We have to find those two also. Next parameter is overall current gain. That is known as AIS. AIS is equal to output current by input current, IL by IS. That is nothing but minus I2 by IS. I am going to raise minus I2 by IS as minus I2 by IS as minus I2 by I1 into I1 by IS. We know that minus I2 by I1 is current gain, AI, minus I2 by I1 current gain into I1 by IS. This is equation, sixth equation, continuation. Similarly, we have to find I1 by IS. So this circuit I am taking. So here if you if you transform this voltage source into current source, that is a source transformation, then in place of voltage source you can take current source. Similarly, in place of series resistance you can take parallel resistance. That is a source transformation, voltage to current source transformation. So this is the main voltage source to current source I am going to transform. Then in place of voltage source, current source, in place of series resistance I am taking parallel resistance with here we have Zi parallelly we have another resistance. Then the voltage across Zi is V1. Here the voltage is V1. Then from this I am going to find I1 is equal to Rs by Rs plus Zi. Opposite resistance by total resistance into current source, current division rule. So I1 is equal to Rs by Rs plus Zi into applied current source Rs by Rs plus Zi into Is. From this I am going to find I1 by Is. Is equal to Rs by Rs plus Zi. This one you can substitute in the sixth equation in place of I1 by Is. Then AIS is equal to AI into Rs by Rs plus Zi. There is a overall current gain in the transistor amplifier circuit. Similarly, you can find overall voltage gain AVS. Same as the current gain, can go for voltage gain AVS. Voltage gain is equal to V2 by Vs. Output voltage by input voltage. Vs, V2 by Vs, V2 by V1 into V1 by Vs. I am going to write this V2 by Vs as V2 by V1 into V1 by Vs. If you cancel this V1 and V1, then V2 by Vs you will get. So then what is the V2 by V1? We know that voltage gain AV into V1 by Vs, V1 by Vs. So we have to find V1 by Vs here, that is the unknown. So for this purpose I am going to use this voltage source equation, voltage source circuit. This is a voltage source Rs and Zi. Here we have input resistance Zi and the voltage across the Zi is V1. Then similarly you can find V1 is equal to then opposite resistance by total resistance Zi by Rs plus Zi into applied voltage Vs, voltage division rule, Zi by Zi plus Rs into applied voltage Vs. From this V1 by Vs is equal to Zi by Zi plus Rs, Zi by Zi plus Rs. This one you can substitute in the 8th equation, this equation. Then AVS is equal to AV into Zi by Zi plus Rs, Zi plus Rs. This is the overall voltage gain in the transistor amplifier. Similarly you can find another parameter, that is power gain, that is power gain. Power gain is equal to voltage gain into current gain. Last parameter, power gain is equal to voltage gain into current gain. Already voltage gain and current gain formulas we derived. If you multiply both two, then you'll get power gain. This is overall exact analysis for the transistor amplifier. If he may ask CE configuration, you can write all the formulas. Then in place of HI, HR, HF, HO, you may write HFE, HRE, HOE. Then you'll get a CE configuration. Similarly, common base configuration, he may ask exact analysis. You can go for HFB, HOB, HRB, like that you can write in the final formulas. That is the only difference. This derivation is common for all CE, CB, CC configurations. Only H parameters only changing. This is a very important question and compulsory question. Thank you.